All right, so welcome everyone. How's everyone doing today? Are your brains full yet? They should be, right? So my name is Guy Royse. I'm a developer advocate at Redis. This is my talk, Tracking Aircraft with Redis and Software-Defined Radio. I'm using Redis and Streams in Redis, so I changed the name of the talk, but I haven't updated my slides yet. So Tracking Aircraft with Redis and Software-Defined Radio. I'm Guy Royse. I'm a developer advocate at Redis. There are three things on this slide that I like to say that matters. One of them matters to me, one of them matters to you, and one of them matters to my boss. Any guess what the thing that matters to my boss is? Yeah, he wants you to know that Redis is more than just a cache. Who here has used Redis? Okay, who's used it for something other than a cache? That's more than usual, but not a lot. And so one of the things we're going to look at today with Redis is you can use it as an event stream. It's got an event streaming data structure. Usually when I ask what people have used it for besides cache, it's usually message broker or session storage, sessions management. So those are common uses as well. So that's the thing that matters to my boss. The thing that matters to me is that Twitter ID right there. I derive my sense of self-worth off of how many people follow me on social media, so please give me a follow on social media. And the thing that matters to you more than anything, the most important thing, is this URL right here, github.com/GuyRoyse. So I've got my code and instructions and samples for all the talks that I do, including this one. And there'll be a QR code to this specific repo at the end, so you don't need to like grab that or anything. And anyone here a ham radio operator, amateur radio operator? So well, that leads me nicely into my next slide. That's my call sign down there. I'm Kilo Echo 8 Victor India Yankee. So if you are into ham radio, that's how you can find out all about me. And I like to say that I'm not an expert because ham radio is a big field. Radio is a big field. Event streaming is a big field. Redis is a big topic. I've probably got a lot of expertise in Redis at this point. I've worked there for several years. But I'm not an expert when it comes to radio. It's a big topic, and it's a big topic that I'm just starting to get into. I'm just starting to explore. And so I'm not an expert, but since no one here actually is a ham radio operator, what I actually mean to say is that I am totally an expert, and you should believe everything that I say. So, no, I'm not an expert. I'm a fan. And so what I like to do is I'll get a subject I'm interested in, and I'll dive into it and learn all kinds of stuff, and then I'll get excited and want to share it with everyone. So thank you for letting me indulge my hobby. A little bit of a warning about this talk. Maybe this isn't a warning. This is just why this talk will be awesome, perhaps, is there's going to be a lot of demos. Because really, what I've done is I've brought a bunch of toys, and we're going to play with them. Sound good? All right. And the other thing, the other warning about this talk is that it's going to be all over the place, because I'm kind of covering a lot of stuff. And I've narrowed this down, and it's still got a lot of stuff. And so hopefully I can get this all done at the end of my 45 minutes, which I think is, well, I've got 40 minutes left. So, and the reason this talk's going to be all over the place is I'm going to be talking about radio and the kinds of information and communication that happens on radio. And specifically, I'm going to be talking about software-defined radio. I've got a software-defined radio dongle plugged into my computer right now. We're going to talk about it, what it is, what you can do with it. We're going to talk a little bit about aircraft and the kinds of data that they broadcast. I've got a special antenna here. This is not a magic wand. I'm not Harry Potter, or well, Hagrid. I would be Hagrid, right? You know, Expelliarmus, right? No. This is an antenna specifically designed to pick up aircraft transponder signals that we're going to use. I've got another one here, which is just it's designed to sit on top of your car and attach magnetically. And I can use that to transmit or receive 2-meter and 70-centimeter signals, which is VHF and UHF, which hams operate in. So we're going to play with all these toys. And I've got this really cheap radio that I bought on the internet for like $25. We're going to be talking about aircraft. We're going to be talking about event streaming a little bit. And specifically, we're going to talk about how event streaming works in Redis. Because I work for Redis, so of course, my demo uses Redis, right? But don't worry, this isn't a sales pitch. It's mostly about the radio. And I'll probably end up skimming through all the code because I'll run out of time. So, first question. What the heck is software-defined radio? Has anyone here ever picked up a software-defined radio and played with it? A couple of you? Okay, a few of you. So I like to describe it in sort of a couple different steps. It's a radio that you plug in your computer. So this is the RTL SDR dongle. I bought mine, I think it was about $30 on Amazon US. And it's a radio. You plug it into your computer. It's got a port on one side for an antenna. So you plug in a little SMA antenna in there. These are all plugged in that way. It's got a USB port on the other side. And what it does is it samples all the signals from the air and then sends them down your USB port. And then your software can deal with that. The other thing that you have is, I came from the United States with this. And so if I'm traveling internationally with my software-defined radio, I also need to make sure that I use proper labeling. TSA never figures it out. So it's a radio that you plug in your computer. It's also a regular radio, but with less stuff. So what do I mean? So these two radios here, actually the one on the right is this radio right here, or a very similar version of it. And on the left here, we have a higher-end Kenwood HF radio. And these radios have circuitry to both receive signals from the air, but also has circuitries to tune it, to do noise reduction, to actually demodulate. There's a bunch of hardware in here that does all these things that you want to do to be able to manipulate these radio signals. Well, a software-defined radio has the parts that receive and tune, but it doesn't have the parts for demodulating and decoding and actually pulling that data out. And so it's a regular radio with less stuff. And that means it doesn't have to have as much hardware, which means it's cheaper, which is cool. And so you use software to do the rest. And so that's sort of in a nutshell what software-defined radio is. So thank you for attending my TED Talk. So, it's easier. I mean, I've kind of described what it is, but it's easier to just show you. So I'm going to do a quick demo here. And I'm going to attempt to type one-handed here. So that'll be exciting. Okay, you see my desktop? That's good. I'm going to run a tool here called SDR Angel. And hopefully it launches successfully. And it's currently hooked up to this antenna right here. And what I'm going to do is I'm going to find a local FM station, just a broadcast radio station. Hopefully there's not music on it, because I don't want anyone to get a copyright strike. And we'll go ahead and hit play here. And let's go to 0887. That's usually the bottom of the AM band, or the FM band. Set the destination down here. Let's see. Make this a little bigger. Let's see if we can see any signals in here. So what you're seeing on the right here is the waterfall. This is just a picture of the radio spectrum. There is a radio station right there at 89.0. Let's see what it is. Hopefully it's not music. But you can clearly see the signal coming in, right? So this is coming in this antenna right here through the software-defined radio into my computer, which is decoding it using software. And if I go here and go to Broadcast FM Demodulator, hit apply, and, well, it's making noise here. I don't think it's going out to the right audio source. I don't think I got it set up right, but let's see if I can turn the volume up. No, it's not coming out. Well, just trust me that you can decode this. This piece of software is actually kind of fiddly. It's got two big flaws, I think. I mean, it's really cool because it does a lot of decoding and demodulating. Its two big flaws are, one, I can't change the font size on the Mac. Now, amateur radio is renowned as a hobby for old people, right? The old guy that's sitting there in his house, he's retired, and he's talking to people all over the world. And you'd think for a hobby for old people, they wouldn't use such a small font, because I can't read it. The other thing is this is actually a really complex piece of software to use. It's very powerful, but it is very complex. But you can see the signal there. And I'm going to go ahead and do another one here, just to show you that this is real. I'm going to go ahead and do a narrowband FM demodulator, NFM demodulator right there. Hit apply, and then turn the decimation down here. And that should work. So you notice the waterfall just got slower. So you can choose to get, you probably heard that. You can choose to get a finer sample, more finely grained sample rate, but it's slower. So you don't get as much width. So I don't know what that is, but I'm going to go ahead and generate my own signal because I can. So I'm going to move over here so I'm not as close to the antenna, but you'll see Here we go. Sorry, I'm making the camera people do their job. I'm making your job hard. You're doing a great job. So I'm going to transmit something on the radio. I'm licensed to operate in Lithuania because of the class of license I have in the US. And so let me turn my radio on. And we'll send something here. I think it's legal. Hopefully I don't get arrested. If I get arrested at the end of this talk, it'll be the best talk ever. So, this is Lima Yankee stroke Kilo Echo 8 Victor India Yankee at the Build Stuff conference doing a radio check. And so you saw the signal coming through there. It got clear all of a sudden. I think there's someone else on the signal. There's probably a lot of noise from all the equipment over here. So I'm going to turn this off. So that's what a software-defined radio does. It's radio with extra steps. But it's actually pretty cool because audio isn't the only thing that you can do with software-defined radio. So let's go ahead and quit this, get back to my slides, and we'll talk about some of the things. Now, the challenge we're going to have with this talk, of course, is going to be that we're inside of a building, and we're in the middle of a building. And so a lot of signals that are out there are going to be hard to get in here, but we're going to do our best, and I've got some backup plans. So we'll talk about some of the hardware involved here. So I've got some of my toys here, but I have a lot more toys back in the US, back home. I've got, of course, this RTL SDR dongle, which I've got one right here, plugged in. I've got some in the bag, but I don't need to dig them out. The bottom line is it looks like that. You plug it in, it does its thing. The SDR dongle is about $25, $30 US. Pretty inexpensive. It's receive only, and so you can't transmit with it. I don't know what the laws are here in Lithuania. In the US, I am allowed to listen to any transmission. If it's encrypted, breaking that encryption would be illegal, but otherwise, you're free to listen. There are things that I'm able to listen to and I'm allowed to listen to, but I'm not allowed to share. So one example of things that get sent over the airwaves are pagers, like the old text pagers, you know, the kind drug dealers use. I mean doctors. The kinds doctors use. Those are broadcast over the air in clear text. And so you can read all these messages from nurses paging doctors saying that, you know, Mrs. Smith in room 307 needs her colostomy bag changed, which is very illegal for them to send that over in the clear, but it happens anyhow. So all kinds of stuff you can pull out of that. It's really fun reading about Mrs. Smith and her issues. But you can pick that up. This particular kit here has an assortment of antennas that come with it. I think it's like about $50. So relatively inexpensive to get into, receive only. You can also use it to listen to HF radio or shortwave radio. So this is radio that would bounce off the ionosphere and propagate around the Earth. And this is a good antenna that will do that. I have this antenna at home, and I have used this antenna. I set it in my kitchen window. And with this laptop right here, and this software-defined radio right here, and that antenna, I picked up in Columbus, Ohio, which is like halfway between New York and Chicago. I picked up a radio station in Lhasa, Tibet. It's literally on the other side of the world. How cool is that, right? So I found that with this SDR, I could pick up local stuff pretty nicely, but I needed a better antenna to pick up the remote stuff. So I got this kit. And then the final thing I kind of bought was this up converter. So this particular software-defined radio, the way it accesses the lower frequencies is a hack, and so it's noisy. And so I bought an up converter, which is designed to listen to the lower frequencies, and then converts it to a higher frequency that the software-defined radio can work with. And then it lets you get less noisy signals. If I were to do this over again, I'd probably buy the kit on the end first, instead of buy, learn, buy, learn, buy, learn. Ultimately, this resulted in me buying a bunch of actual radio equipment for transmission as well. And so while this particular handheld here cost me like $30, I also have a $1,300 rig that I just bought a few months ago. It becomes an expensive hobby if you're not careful. But this is some of the hardware you can use for the software-defined radio. This is very available on Amazon. Anyone can use it. It's a lot of fun. For software to talk to the software-defined radio, there are 4 main options that I've looked at. One is called SDR Sharp. Any guess what language this is written in? It's totally written in Java. Yeah, it's an Electron app, but it's all JavaScript. No. SDR Sharp, unsurprisingly, only runs on Windows. It is written in C#. It's very full-featured. It's easy to use. It's got a massive plugin community where people write plugins. It's a pain in the butt to set up. It's very fiddly, but it is very, very powerful. It's the most popular one. I've messed with GQRX. This one runs really nicely on Linux, and it's an older package, and so it runs on lower powered machines, and so you can run this on a Raspberry Pi. And so if you want to go really low-end computing, you can do that as well. You've got Cubic SDR. This was the one that I found that would work on my Mac. And it's okay. It's a little basic, but it does the job. And if you're a Mac user, this is not a bad option. But the one that I recommend and the one that I like is the one I was using earlier, is SDR Angel. SDR Angel is, well, actually, if you have a software-defined radio that transmits, it will do transmit and receive. And it's got a lot of baked-in options. You don't need plugins for it because they've got all the plugins you could ever possibly need. And so in addition to decoding audio, like we half saw, you can also decode data formats that are out there in the software. You don't have to use any weird plugins, or like with SDR Sharp, you tend to tune to a frequency that has data in it that's encoded in the audio, and then you have to like use virtual audio cables to then pipe that to other programs that they can then decode it. SDR Angel will do all this inside the software for you, so you don't have to mess with getting like 10 pieces of software to work with each other. So you can just work with one piece of software. It's got a steep learning curve, but it's more powerful. Although it does tend to crash every now and then. So don't do anything important on it. And I mentioned that there's audio communication, but there's also data. And there's a lot of data communication still happening out there over amateur radio frequencies and non-amateur radio frequencies. And probably the most common or popular one is Morse code. People are still using Morse code. The reason they use Morse code is because you don't need a lot of power. There's not a lot of bandwidth that you're manipulating with Morse code, just a little narrow sliver of it, so it doesn't take a lot of power. And with 1/4 of a watt and good conditions, you can reach anywhere in the world with Morse code, and if you're a skilled operator, which I'm not. It's arguable if Morse code is actually data, because it's more like handwriting. And so when you use Morse code, you're keying, and humans will tend to like not do the last bit quite as long as the other one and that kind of stuff, and it creates sort of a signature or a handwriting. They call it a fist. And so computers can sometimes struggle with decoding Morse code. There's a project that someone's working on to use AI to decode Morse code, which is an obvious solution to that problem, but it's such a niche need that no one's putting any compute resources to it. But that's sort of like the original data. Actual data that's still really old is RTTY, radio teletype. This is used to send like text data over HF radio, super long distances. So you can have like a field reporter in Cairo, Egypt, reporting that Indiana Jones has just gotten the Ark of the Covenant, and then then pick it up in the U.S. And it was used for that. Hobbyists use it now as a way of basically doing chat back and forth, and so they can type at each other at 300 baud, because why not? A more modern data format is called APRS. This is the Automatic Packet Reporting System. APRS are sort of these packets of data that different things can sort of just broadcast out and say, hey, I'm doing this thing, or I'm at this location. And it grew out of packet radio. So packet radio is it uses a standard called AX25. AX25, anyone here ever do anything with X25? No one. I'm the old man in the room. So X25 is an old networking protocol, and AX25 is basically the amateur radio version of it. You can think of what amateur radio, packet radio does, is sort of like a big Ethernet. So on Ethernet, you broadcast something, and if there's a collision, you rebroadcast it. Packet radio is doing that same basic thing, where, but instead of having a wire that everyone's communicating on, it's just the airwave. It's just being broadcast out into the air. And instead of using like a MAC address to identify your network card, use your call sign to identify the particular broadcaster. And APRS grew out of packet radio because packet radio was trying to establish connections, and you could actually do TCP over it. But in practice, TCP connections are hard to maintain over radio because it's not as reliable as a piece of wire. And so APRS is more of a broadcast-oriented thing, and if you get the packet, you get the packet. If you don't, you don't. You're not trying to establish a communication, two-way communication. You're just announcing things, and if they receive it, they receive it. APRS is particularly neat because it encodes in it location information. So when I broadcast an APRS packet, it's got my latitude and my longitude. And so people will hook these up to their vehicles when they drive around, and then to announce to all their ham buddies that, hey, I'm driving around. What I think is funny is you can actually watch these, and it's very clear that people are speeding. You know, some of the software that talks to it will even calculate their speed. It's like, oh, you're doing I'm going to use freedom units here, sorry. You're doing 75 miles an hour in a 65 mile an hour zone, and so I know you're speeding. But people hook them up to their vehicles as a way of tracking them. And people also hook them up to weather stations. So you have a little weather station on the top of your house, and it will broadcast out the weather conditions every 20 minutes. People will use APRS to just, as an individual with a radio like this, not exactly like this one's not APRS capable, but a handheld radio, they can send a packet out and say, you know, to addressing another ham radio operator and use this as like a chat mechanism where I send a message to you and then you send me one back and it goes back and forth. So these all get broadcast out, and then people can receive them. So individuals can just listen to these packets and receive them and decode them and look at what's in them, and that can be fun. But repeaters also pick them up to extend their range. So when you send an APRS packet out, you say, repeat yourself a couple times, and then a tower will pick it up, repeat it, and then decrement the counter. And so it'll do a couple of hops. And where I live in Ohio, I live in smack dab in the middle of Ohio, and I can pick up APRS packets throughout the entire state this way. So something up in Cleveland, Ohio, which is probably about 200 kilometers from my house, will hit something in between and hit something in between, and then I'll pick up the packet. And so repeaters will repeat these so that you can get extra range. And most interestingly, it's also got an internet component. So the APRS packets, some of these repeaters are iGates, and so packets will come into the internet, and then you can consume them through a cluster of servers. And there's a website where you can look at these and see all the packets in an area. And there's also corresponding services on the internet can generate packets and transmit them out. So for example, if I had there's a one called WXBot. And if you send WXBot your location, it will send you a weather forecast back. And so your message goes out, hits a gate, goes into the internet, and then the bot picks it up, generates a message back out, and then the tower that you went in on generates the message back out. So you can actually do internet communication this way. The other one, there's a WhatsApp bot that you can actually send WhatsApp messages to people, and they can reply in WhatsApp, and it will go back out through the route, through the internet, through the radio. So like if you're out hiking and you don't have a cell phone distance, but you have a radio, you could get a hold of someone. So it's really cool the way it works. It's an international standard. It's different frequencies in different areas. Here it's at 144.8 megahertz. And there's a website called aprs.fi, which will show all the activity in your area. I checked the website here. There's not a ton of activity in Vilnius, unfortunately, so I haven't been able to pick up any APRS packets, so I'm not going to try and demo it. But I will go ahead and show you the website here, because I think the website's kind of cool. How are we doing on time? My boss is going to be really upset when we don't get to the Redis content. Okay, there's a browser here somewhere. Here it is. So this is the live APRS map. If I zoom in a little bit, I don't need to hit Command+. So there we go. We are right around here, right? And so here is a station. That is a repeater that's just announcing, hey, I'm a repeater and I'm here. There is something there. That is Lima Yankee 2 Echo November-4. That's the iGate. So if in the area, so if data came in, that would go through that iGate to the internet. I was looking earlier today, and there was someone driving around, and you can zoom out, and this map picks up the whole region. So like if we just zoom way out, we see that there's a repeater over here. Oh, come on, computer. Don't lock up on me now. There we go. For LY1 BWB. And so not a ton of activity here in Lithuania. Quite a bit in Poland. Of course, as you get to the coast, you get more west, it gets more crowded. But if you've got a radio, you can receive these packets that are being broadcast locally, and you can send to them, and it'll go in through that iGate, and you can check it out. So let's go back to my slides. Okay, that was the demo. Another data format that's out there that's kind of fun to intercept, maybe not here, but if you're near the coast, is AIS. This is the automated identification system that ships use. And so ships will broadcast their heading, their name, their information about them. So you know who they are, where they're going, what speed they're at, their location, that kind of stuff. And AIS data is broadcast by all this watercraft. They got the latitude, longitude, speed and heading. Here are the frequencies. And much like the APRS, this is all gathered up by a couple of websites. And there's land-based towers on the shore that pick up watercraft. And there's also satellites that pick them up when they're over the ocean, because obviously you can't put a tower in the middle of the Atlantic Ocean. And so you can intercept this. SDR Angel can actually intercept, decode, and put on a map all this information. I'm not going to demo this because there's not an ocean close enough. But if we were on the Baltic Sea, there's definitely traffic out there. And it's got a similar interface to APRS.FI. This is the northeastern United States with the Great Lakes. I live, where's my mouse? It's way over there, isn't it? There we go. There's my mouse. So I live right here. And so you can see there's traffic here on the Great Lakes. There's the Mississippi River right there. There's the Ohio River. Here's the massive cluster of ships that is New York City and the harbors there. And so you can go to this website and check this out. And if you are on the coast, it's a lot of fun to pick up these signals. And, like, you'll see a ship on the ocean, and let's say, I wonder what ship that is. Well, you can find out. You can use your software-defined radio, and it'll tell you the name of the ship and its identity and where it's heading and all sorts of stuff. So there's lots of neat data out there. This is not the only data that's available, of course. In addition to AIS, we've got the star of the show, but I'm going to mention a couple other fun data things that are out there. So I mentioned the pager thing already. That's entertaining. But there's all these IoT devices that are broadcasting, and there's actually a lot of, you can pick those up. And sometimes it's like things like your security systems will broadcast stuff, your car key fobs will broadcast stuff, your thermometer, your thermostat in your house will broadcast stuff, and you can intercept these. What I do at home, I have done at home, is my water meter and my natural gas meter both broadcast their number periodically, and I can pick that up. And I can pick up all my neighbors too. I don't know which one belongs to whom, but someone's using a lot of hot water. But my favorite thing that's just kind of random and weird is, you know how your car has that sensor that tells you when your tires are flat? Well, there's no wires coming from your tire to the car because it's a wheel, right? So it uses radio. And I don't know this, but I suspect they actually charge from spinning. There's probably a little generator in there. That's how I would engineer it. But they broadcast this over radio. And you can pick that up. It's got a range of maybe, 20, 30 meters. But, if someone drives past your house, you can pick it up. And so I'll sit there and just sort of watch the tire pressure sensors and find out who's driving past my house that has a flat tire. They also report the temperature in addition to the tire pressure, so, because that's part of the calculus. It's like, if it's cold, that pressure's going to drop. But, as it warms up, it should expand. Interestingly, I think Volvo was one of the early cars to come out with this feature, and it didn't occur to them that they needed to encode these with identity at all. And so if you had the same model of Volvo parked next to you, and they had a flat tire, you had a flat tire. So there's lots of fun data. There's satellite data. So the NOAA weather satellites that the US launched are still broadcasting images, and so you can get live photos of space as the satellite passes overhead. There's geosynchronous satellites that transmit all kinds of weather data. So there's a ton of interesting data that you can pick up. But the one we're going to look at today is ADS-B. ADS-B is the Automatic Dependent Surveillance Broadcast, which is the transponder information that comes from aircraft. So every airplane in the world, military or otherwise, civilian, doesn't matter, will broadcast transponder information. Now, the military can turn those off for all the obvious reasons. But every now and then I'll pick up US military aircraft where I live, and it's kind of fun. Every aircraft is broadcasting this telemetry at 1,090 megahertz. It includes the aircraft ID. This is a unique 3-byte number written as 6 hexadigits that identifies that aircraft. There is data encoded in this number, so like if it starts with an A, that means it's an American aircraft. If it starts with C, it's Canadian. And then there's other codes that are less mnemonic, but America and Canada gobbled them all up first, so sorry. This one happens to be Elon Musk's, because reasons. They broadcast their call sign. Usually this is their radio call sign, so this is an American radio call sign, a station, N628TS, which is also Elon Musk's. I do not encourage nor endorse building a service to track Elon Musk, but it would be easy to do. And so the call sign there, a lot of commercial flights tend to use their flight number for their call sign. So like you'll have WZZ1234 for like Wizz Airlines flight 1234. The US military tends to put in whatever the pilot thinks it would be cool. And so I was in Poland one time, because I was giving this talk in Krakow, and I saw this aircraft come by. It was Duke 55. I'm like, that's got to be a U.S. military aircraft. Sure enough, it was. Didn't show up on FlightAware, but it showed up on my software-defined radio. They broadcast their altitude in feet, because that's the international standard for aircraft, for altitude is in feet. Their speed in knots. Their heading, of course, in degrees, and their location with a latitude and longitude. And so there's a piece of software that does this, that will talk to the software-defined radio and put this on the screen for us. And it's called Dump 1090. Dump 1090, through a wonderful coincidence, was written by the same guy who created Redis. I wish I was making that up. But he spent a weekend, Christmas holiday with his family. He had to write C code instead. He wrote this program. And what it does is it talks to the software-defined radio, decodes the packets of data that are being broadcast from the aircraft, and puts it on the screen. And so this is a screen capture from around my house in the US. Here you can see the one that says DABJet 55. That's a US military aircraft. I happened to catch one when I was doing this screenshot. I live close to Wright-Patterson Air Force Base. They're about 100 kilometers away. So I see those occasionally. And so I'm going to attempt to use this antenna to pick up what aircraft I can off the air. We're going to see if this works. And if it doesn't, I've got some stuff I've recorded that I can play back, which won't be as cool as real data. But if it works, it'll be great. So let's go ahead and see if we can get Dump 1090 to work. I'm going to set my mic down because I actually need to use, I need to use both hands. So let me turn this off and I'll turn it back on, and I'll be right back. Oh, a mic stand. Woohoo. It's called technology. There we go. Like, we're just going to watch him move the mic stand around. Okay. Let me go ahead and... There we go. Let me go ahead and... I'm just going to yell for a second while I do this, and then I'll get the mic back in my hand. So I've got to unscrew one antenna and put another one on. It's very exciting. Okay. There we go. Okay, so I'm going to run dump 1090. There it is. So dump 1090 here. I'm doing dump 1090 -net. And the -net means open up some sockets, some ports that I can transmit data on. And so you can talk to dump 1090 and get data out of it. -interactive gives us a nice interactive display. And, okay, hang on. right, try it again. There we go. So I'm going to hold this up, and we'll see if we pick anything up, but we probably aren't going to because we're in the middle of a building. And I tried recording stuff from my hotel room, and there was like one airplane. I'm like, I can't find any aircraft. There's nothing to show. My talk's going to suck. Okay, we're not getting anything, so let's go to the backup plan. So if we look in here, that's not the one. That's the one. I've got a little, let me make sure I've got the right file here. So there's a little bit here, but I'm going to go with, I'm going to record something I recorded from home, because there's plenty of data here. Yeah, and in here, we're definitely not going to pick up the nearest plane in Poland. We'll move that there. Now, if I look at that capture.txt, we see we got stuff from, this is from April of this year. So I'm going to go ahead and run, I've just got a little shell script that will inject these into dump 1090 so we can actually see something. If we find something local, the antenna will still pick it up. But if I go back here, please work. Best failed demo ever. Yeah. It is totally not doing anything. That sucks. Let's try it again. Oh, npm start. Helps if I run the right thing. There we go. Okay, so now stuff's starting to come in. So this is what it looks like. If we had actual data, it would look much like this. So this is what dump 1090 does. So in dump 1090, it spits out the data that's being fed into it over sockets. So if I do netcat to localhost, port 30,002, this is the data that's being fed into it. This is the hex data that would be coming from the aircraft. And if you knew the format of this, you could parse this and do something with it. Well, you don't have to do that, because it also does this. This is very easy to parse. And so all I have to do to consume this data and put it into Redis and put it on a map is to connect to a socket, parse CSV data. But it's even easier than that, because this is a standard format and someone wrote a node library. And so I'm going to go back to my slides here and show you that format. And how am I doing on time? I'm doing terrible on time, ain't I? We've got 5 minutes. Okay, so I'm going to skip to the demo where we actually show this working here really quick, because I got 5 minutes left. And I don't want to stand between you and your break. But I'm going to say that basically what I've done is I've built a piece of software that will pick up these broadcasts, shove them into an event stream in Redis, and then put them on a map. That's basically what I've built. I'm using Redis Stack to do that, which has JSON data structures that is worth checking out. It's a Docker image, very friendly version of Redis. And yeah, let's just skip all this badly designed microservices. And let's go ahead and hop to the demo at the end, because I have way blown through my time. Okay, yeah, there's the demo. Okay, so I'm going to show you in here. I've got a bit of data in here. So if I go into Redis here, oh, come on. This is like everything failing. That's not the one I want. Okay, well, let's just go to localhost. Okay. I hate it when this kind of stuff happens. I'm letting you down. Oh, I know the problem. I actually need to run the radio ingester. Docker compose up. So what this is going to do is it's going to talk to dump 1090 and shove them into an event stream in Redis. Did Docker crash? That's my problem. Why is Docker not running? What the hell? So my rough plan, by the way, is to later on go up to the sky bar and do this. So if I can't pick up aircraft from the sky bar on the 22nd floor, I'm not going to pick up anything anywhere. So let's go ahead and start Redis. There we go. Close that. Docker Compose up. Way happier. And then Docker Compose up. This one is going to read that stream, shove it into JSON documents, shove it into an event stream, shove it down a WebSocket so that we can view it. And if we go into the browser here, wow, it's going to look at our location here. Now we're not finding any aircraft here. If this antenna picks them up, they will show up. But I'm going to go all the way over to my house where you see that big cluster of aircraft. And these are the aircraft that I picked up with an antenna hanging out my bedroom window. So for scope here, this is Columbus, Ohio. I live right here in Westerville. Ohio is about 400 kilometers across, roughly. So these aircraft here are probably 150 kilometers away. So I'm picking stuff fairly far away, 4 months back in April. So, and if you click on these, it will give you the information about them. Now, if I click on them, it's going to take you to FlightAware, and this data's like 8 months old, so it's not going to do anything meaningful. But yeah, so this is the little aircraft thing. That's my demo. I've got 2 minutes left, so I think I'm just gonna finish. Is that okay? Let me go back to my slides here. I will show you one thing here now that Redis is up and running. This is the data that's coming in here. So here's the event stream that's being fed in, and then here is the JSON documents that are being generated. And so this is all being stored in Redis. And then I've got a socket, a WebSocket that will go down. So that's what I've got. Let me get back to my slides here and just do a quick CTA. I don't think we have time for questions. I blew through that, didn't I? Resources checkout, and a couple of things that we have at Redis. We got a Discord server if you're using Redis and you have questions. You can go out to Discord. We got free classes. We got cloud versions. And the most important thing is the QR code that will take you to the slide deck and the demo and the code and all the stuff that you would want to play with. You can trust this QR code. It will never give you up nor let you down. My name is Guy Royse. Thank you very much.